Yeah, so let's discuss this question paper. Hmm. Uh, let's start from the scratch, right? So first, read the question carefully. Question is easy, medium, or difficult whatsoever. Read question properly. You will find a 50% question gets solved at that time only. So the question is the vapor density of a gas A. We have gas A and its vapor density given is 4 times that of B. If the molecular mass of B is M, then the molecular mass of A is. We have to believe in the process, and you know there that vapor density, how it is related, molecular mass is equal to 2 into Vd. So vapor density is equal to molecular mass by 2. So this time I can say that vapor density of gas A, if you write here the vapor density of A is 4 times that of B is equal to 4 times vapor density of B. Fine. Now in this case, given the molecular mass of B is M, molecular mass of B is M, then the molecular mass of A is so simple one. We can find here the relation. Here we write here the molecular mass of this one given. So the molecular mass 4 into Vd. Vd can be written as molecular mass by 2. So we write here into there that Mb by 2. Can we write? Because molecular mass of B is M, so Vd of B is equal to molecular mass of B by 2. And here, what is this? That also we have to find molecular mass of A. So we write here the molecular mass of A by 2 instead of the VDA. So what we get finally here, this 2 and 2 is cancelled. So this one, molecular mass of A is 4 times of there that B. So given now, there the 4m. Molecular mass of A is 4 times this one cancel, and so A is equal to 4mb. And as per the question, if the molecular mass of B is M, then molecular mass of A, so it is clear, molecular mass of A is equal to 4 times of this one, so answer is this one. Okay, fine. Good. Move to the next question. Yes. On analysis of a certain compound, this is the second question. Question number is written one only on every page. Please ignore that one. Okay. So on analysis of a certain compound was found to contain iodine in oxygen. There is one compound which contains iodine in oxygen. Okay, fine. Iodine in oxygen. Iodine and oxygen. And given in the ratio of 254 gram of iodine in 80 gram of oxygen. Here given this one, it is basically iodine. This one is oxygen. When we say oxygen, we write O2. When we say iodine, we write I2. Okay. This one given there the 254 gram of iodine in 80 gram of oxygen. 80 gram of oxygen. Now, when we form the formula, when you consider the compound, there we don't consider I2 molecule, we consider the iodine atom. We consider there the oxygen atom. So, how many moles of oxygen atom, there the iodine atoms are here? So, we can find easily there the number of moles of N of iodine atom is equal to how much? 254 divided by its atomic weight. What is the atomic weight? Anyway, you should know that it is given there the 127, right? So 127 2 are 254 2. The number of moles of iodine in this compound is there the 2. Contain iodine and oxygen in the ratio of 254 gram of iodine in 80 gram of oxygen. So number of moles of oxygen atom is equal to 80 gram given 80. What is the atomic weight of oxygen? 16. So is equal to what? 16 5 ja, this one. So what is the compound here? Compound is, so compound is I2O5. Correct. Good. Move to the next question. Read the question. Out of 1 gram dioxygen, it is 1 gram dioxygen, 1 gram atomic oxygen, and 1 gram ozone. The maximum number of, understand, maximum number of oxygen atoms are contained in. Okay, fine. Let's write here. 1 gram dioxygen, 1.0 gram O2. 1 gram atomic oxygen, 1 gram oxygen atom. 1 gram of ozone, 1 gram of ozone. The maximum number of oxygen atoms are contained in. Okay. So 1 gram of O2. So what we have to think here, how to find here, just to see the maximum number of oxygen atoms we have to find. It's not the molecule of O2 or there the O3. It is the atoms present in one dioxygen. 2 oxygen atoms are there. That's why number of moles of dioxygen is here. Number of moles we can find how there that 1.0 by 32. This is the number of moles of oxygen. Number of atoms, their number of oxygen atoms is equal to 1.0 by 32 into 2, because in 1O2, 2, this many number of oxygen atoms, number of moles of oxygen atoms. So there the number of atoms is equal to there the into Na Avogadro number. Correct. Now 1 gram of oxygen atom. So number of moles of oxygen atoms is equal to 1 divided by 16. These many moles. And there these many moles, then how many atoms? 1.0 by 16 is the number of moles of oxygen. This has one only into there that Na, these many oxygen atoms. In this one, 1.0, 1 gram, molecular weight is what? 48 grams. So the number of moles, in order to find number of moles, this is divided by 48. This number of moles of oxygen atoms, yes, 1.0 divided by 48 is the number of moles of O3. When that is multiplied by 3, it means number of atoms, number of moles of oxygen atoms in that one. In here, into Na, absolute number of oxygen atoms. What do you find here? 2 16 ja, 3 16 ja. You find here equivalent. So number of moles of, question is there what? Question is there oxygen atoms. Maximum number of oxygen. Number of oxygen atoms is same in all the cases. Correct. So we have one option, all contain same number of atoms. We have this option. Move to the next question. Read this one first. The atomic masses of two elements given, atomic mass given, A and B are 20 and 40. So we write here, if X gram of A contains Y atoms, how many atoms are present in 2x gram of B? Okay. So atomic mass of two elements A and B, right here the A, atomic mass of A is equal to 20, atomic mass of B is equal to 40. Given X gram of A contains, okay, the X gram of A, we have to see this one contains Y atoms. Actually, we should see this one, that what is the meaning of this. X gram of A contains Y atoms. How many atoms are present in 2x gram of B? Okay. So first we have to see this one, X gram of A means what? There that number of moles of A is equal to there the X by 20 moles. X by 20 moles contain here the Y atoms. Okay. Now you see this one. There the how many atoms are present? 2x gram of B. So there the 2x gram of B. The 2x gram of B means how many moles? There the 2x by what? 40. 2x gram by 40 moles. So what is the effective moles here? Number of moles of B. Number of moles of B is basically X by 20. So X by 20 moles only. So X by 20 moles. As yet X by 20 moles contains Y atoms of A. So X by 20 moles of B will also contain Dulmin. Because if I say there the 1 mole of sodium contains Avogadro number of atoms, and 0.5 moles of sodium contains 0.5 Na, and 0.5 moles of Mg also contain 0.5 mole of Mg only, 0.5 Na of Mg only. That's why when mole is same, then there the number of atoms will be same. So X by 20 moles contain Y atoms. Here also we are getting X by 20. So that will also contain Y moles only. Okay. So do we have? Yes, we have. This is the answer. Right now. It means contain Y atoms only. Good. Move to the next question. Question is the largest number of molecules. Very simple. There, the largest number of molecules is in. So let's analyze this one. We have a 36 gram of water. Number of molecules, okay, 36 gram of water. How many moles? 36 divided by 18. 18 is the molecular weight of water. moles of H2O. The number of molecules is equal to, we can take here 18 to the 36. So there that direct we are getting 2 moles. Then the molecules is equal to, there the 2 NaH2O molecules. Correct now? Next given 28 gram of B, 28 gram of CO2, 28 gram of CO2. The number of moles we can find. How we find here? The 28 divided by, what is the molecular weight of CO2? C12, CO2, 12 plus 2 into 60, 32 plus 12 is equal to 44. So 28 divided by there the 44. This is the number of moles of CO2. Then very simple one, 28 to 14 jar, or the 4 7 jar you take. Okay, 4 7 jar, 4 11 jar, 7 by 11, 7 by 11 moles. 7 by 11 means there that's almost 11 6 does 66. So almost it will be 0.6 mole, or there the 0.6 NaCO2. Correct. 46 gram of CH3COOH. C 46 gram of CH3OH. CH3OH. There the molecular weight is 12. A 3 1 4 12 plus 4 16 plus 16, there 32. Okay, so 46 divided by 32 moles of CH3OH. Okay, yes. So what you will do? 23 to 16, 23 by 16, 23 by 16 moles. How much? 16 1 jar, almost it will come around 23 by 16. How much? 1. 1.4 around. Okay, approximate 1.4 NaCH3OH molecules. Okay, good. There the D is what? 58 gram of N2O5. 58 gram of N2O5. 58 gram of N2O5. So 58 divided by molecular weight of N2O5. There's the 14 to the 28 molecular weight of N2O5. 28 plus 16 5 80. This one is 108 gram. On there the 108 moles of N2O5. Let's find here the exact one. There the 58 by 108. This will be around 0.53. Okay, so this will be 0.53 moles of N2O5. You can say here 0.53 Na. So very clear now. Okay. So what is the question here? Question is here, largest number of molecules. Which one is having the largest number of molecules? Here the 2Na. What we have here? 2Na. Here 0.6Na. Here 1.4Na. Here 0.53Na. So which one is the highest? 36 gram of water is the highest one. Okay. Yes. I hope it is clear. Okay. Next one. A compound. Next question. A compound has 50% oxygen by weight. Oh, direct. You can take it. 50%. 50% oxygen. Right. Now 50% oxygen. So we have to find that what is the total weight here and where this one is equal. So we will see this one that A, analyze there the A option wise we have to see this one. ACO2. What is the total weight? CO2 we have in there, the C is 12 and this one is 32. It is not 50%, right? Carbon is 12, this one is 32. There the B, H2O. What is the weight here? This one is 2 and this one is 16. Is it 50%? No. There the SO2. There that SO2, sulfur. How much weight? 32 plus oxygen is also 32 now. Okay. So in this case, we find oxygen is 32. This one is 32. So total weight is 64. 32 gram is this one. Oxygen 32 gram. This one is the 50% by weight, right? Now of the oxygen is 50%. But if you take N2O5, for example, you take here N2O5. N2O5, what you get here? This one is 28 gram and this one is the 80. This is also not 50%. So what's the answer here? Answer is given. This A is wrong. SO2 is the answer. Correct? No? SO2 is the correct one. Okay. All right. Did you get this point or not? That total weight is what? Total weight is 64 gram. Percent of oxygen is equal to what? 32 divided by 64 into 100 is equal to 50%. That's why we say. Okay. Done. Okay. Next question. Chlorine has two isotopes. Chlorine has two isotopes, Cl35 and Cl37. Atomic weight of 2 chlorine 35.5. Then the molar ratio of these two isotopes is okay. We find it. Atomic weight of chlorine is 35.5. What is the atomic weight? Atomic weight is the average relative weight. So you know this one. One is 35, other one is 37. So we take here the 100 moles. We will get here the molar ratio. We take here 100 moles of chlorine. 100 moles of chlorine. And we assume, let's assume X mole of Cl35. We have Cl35X. Right. Then there that Cl37. So Cl37 is equal to there that 100 minus X mole. Okay, fine. And what is this atomic weight? Atomic weight is the average one. The average one. So what is the total weight contribution of Cl35? Okay, Cl35 is there X into 35. What is the weight contribution of this Cl37? This one is 37 into 100 minus X. So this is the total weight of 100 moles. Is it correct or not? This is the total weight of 100 moles. So what is the weight of 1 mole? That is the atomic weight, and that must be divided by 100, and that has been given, that is 35.5. What is 35.5? That is the atomic weight of 1 mole. So we have imagined, assumed here 100 moles, and so weight contribution of 35, weight contribution of 37 isotope, and then we take here the weight of 1 mole. And so that is 35.5 given, because that is atomic weight. We will calculate here. You will be helping me in this calculation. We will write here the 35x plus this one is 3700 minus 37x is equal to 3550, 100 multiplied, right? Okay, so we will take here 3700 minus 3550 is equal to 37x minus 35x, correct? So 3700 minus 3550, please tell me. 550, 600 and 150 is equal to 2x. So the x is equal to 150 by 2 is equal to 75. 75 moles, this one. Cl 35, 75 moles. Cl 37, 100 minus 75, that is 25 moles. So their molar ratio 75 by Cl 35 by Cl 37 is equal to 75 by 25 is equal to 3 by 1. Okay, so 3:1. I hope it is clear. Very simple. Very, only one thing is required, that you should understand the right meaning of atomic weight. Okay, that's good. Move to the next one. What is the question? A metal sulfate has formula MS4. So simple question. Now we have MSO4. Right. MSO4, you know there is a sulfate. Sulfate means SO4 2 minus. That is the negative. So it means this one is M2 plus and SO4 2 minus. That is the case. Its valency is, this is dipositive. NCl is the minus one. So chloride of the same metal will have the formula. Okay, this one is very simple one. So this one is dipositive, Cl is minus. So the formula for of chloride, you know, na, crisscross method, right? So what is this? This one is MCl2, right? MCl2. It is correct, na? Because this one is 2 plus M2 plus 2 Cl minus. Total positive charge 2 plus, total negative charge 2 minus. Then MCl2. This one is given wrong. Okay. Clear? Very clear, very clear, very clear, very clear, very simple one. Next question. We have a gaseous compound is composed of this one 85.7% by mass carbon, 14.3% by mass hydrogen. Okay. So we take here the carbon 85.7%. Their hydrogen is 14.3%. What you can find easily? Oh, let's read the question properly first. Its density is 2.28. Density given. Density is 2.28 gram per liter at 300 K right now in 1 atmospheric pressure. So this will help us to find here the molecular mass. But this data will help you to find 85 point. This percent composition will help you to find first empirical formula. You will get here the empirical weight because you have to find here the molecular formula. So you'll find empirical weight, then you'll find molecular weight from this second data, and then you'll find here the n multiplicity number, right? The multiple factor, and then you will find here the molecular formula. Okay, fine. So 85.7% means what? How many number of moles? Basically, we can do this one, that 85.7 divided by 12, and 14.3% divided by the other one. So how much it is? It is 14.3 only, and this will be 85.712 12 7 ja 84. So 7.71 something, approximately 7.1. Okay, let's check this one also. 7.14. Okay, so no problem. Now there, this one is the number of moles in this one. We take here the simple ratio. For that, the simple number is this one, 7.14 divided by 7.14. This one is 14.3 divided by 7.14. This one you take here the approximately 2. This can be rounded to, and this is basically exactly equal to 1. So 1 and 2, empirical formula. Empirical formula is what? CH2. Fine. Empirical formula is CH2. Now the point is there that you have been given there the density. From density, how you'll find it the molecular weight. I hope you remember. I hope you remember this thing that I discussed. PV is equal to there the nRT, right? And then only I discussed this density, how we find a density, because PV is equal to weight by molecular weight into there the RT. If we rearrange this one, then you will write here the P is equal to weight by volume into RT divided by the M. This thing can be rearranged like this. And weight by volume is what? Weight by volume is the density. So P is equal to dRT by that M. So you can find here the molecular mass is equal to dRT by the P. Very simple one. Molecular mass is equal to dRT by P. Okay. This is the formula here. Good. What value given here? We will find here the molecular mass, because that is density given 2.28. So M is equal to dRT by the P. So we take here D is what? 2.28. That only, no? Yes, 2.28. There the R. What is the value of R? When there liter in atmosphere we have. Volume in liter, pressure in atmosphere, temperature in Kelvin. In that case, the value of R is 0.082 liter atmosphere per Kelvin per mole. Okay, so into 0.082 into there the temperature is given 300 divided by there the pressure is equal to there the one atmospheric pressure, right? How much it comes? Let's calculate this one. 2.28. 1 minute, please. Why not? Let's finish this one only. We write here 2.28 into 0.082 into 300. 56. 56.08. Leave this one that you take here just a round figure, the 56. This one is the molecular weight. Molecular weight is equal to 56. Empirical weight is empirical formula weight. There the 12 plus 2 14. And so the value of n is molecular formula weight, molecular weight empirical formula weight 56 divided by 14. 14 2 is 28, up 14 4 is 4. So n is equal to 4. So the molecular formula is equal to there that empirical formula n into empirical formula. So what we get here? CH2 now, C4H8 given C4H8. Very simple. Only one thing is there. This is just, you cannot say this is the level 1 question. This is the level 2 question because one more concept was involved now. So this formula you have applied. So this is the second level of question. How you are applying here the concept of density based on this one, right? In this one, right? Now, okay. Right. Move to the next question. Next question is carbon compound containing carbon and oxygen. Carbon and oxygen has approximate molar mass equal to 290. Molecular mass given 290. On analysis, it is found contain 50% by mass of each element. On analysis, it is found to contain 50% mass by mass of each element. First, carbon we have, oxygen we have. Total molecular mass is 290. 50% is this one. Very good. So we have carbon. We have oxygen. Okay. Molecular weight, approximate molar mass is equal to 290. 50% by mass of each. This one is 50%. This one is 50%. 50% means there that 145 gram. This one 145 gram. This one is also 145 gram. Very simple one. So how many moles of carbon? So n of carbon is equal to 145 divided by 12. 12 12 is 144. And there the oxygen, N of oxygen, number of moles of oxygen is equal to 145 by there the 60. How many oxygen atoms are there right now? So this will be there 9, and this one is there 12, approximately 144. That is negligible. Okay, and given also no approximately. Okay, fine. So the formula is very simple one. Where is the formula here? C1209. C12 and there the O9. Answer is A. Correct. Move to the next question. A certain compound has molecular formula X4O6. X4O6. Okay. We have X4O6. 10 gram of a compound contains 6.06 gram of X. Right now. 10 gram of compound contains 6.06 gram of X. Then the atomic mass of X. You have to find the atomic mass of X. 10 gram of compound contains 6.6 gram of X. Okay. One thing you see this one. We can find here the percentage of carbon here. If 10 gram contains 10 gram of compound has 6.06 gram, then 100 gram of the compound contains, that we can find. And in 100 gram, what weight of X is there? That is its percentage. A percentage of carbon, it means we know. Okay, fine, we can do it. So we write here 10 gram compound contains 6.06 gram of X. Then I say there the 100 gram compound contains, that is 10 times. So this one is also 60.6 gram of X. Simple one. So you can say the X is 60.6 gram in 100 gram compound. So you can say that percent of carbon percent of X, not carbon, percent of X in X4O6 is equal to 60.6, and we have percent of X is equal to how? If there that atomic mass of X, let atomic mass of X is equal to the A, then the percent of X is equal to, we can write here 4A divided by total weight. Total weight is what? 4A plus 16 into 6, right? 96. Correct now? This one is 96. 4A by 4A plus 96 into 100. This is the percentage of X in X4O6. Is it correct or not? And that you have already calculated, that is a 60.6. Clear? You can find here the A. So here, how will you find here the A? 4A into 100 is equal to 60.6 into 4A plus 96 into 60.6. It is correct now? Right. Just we need some calculation right now. This one is just you find it 60.6 into 4, 60.6 into 4. This one is 242.4a. This one is how much? 400a. This one is how much? 96 into 60.6. 5817.6. You take this one 400a minus 242.4a is equal to 5817.6. So how much it is? There the 400 minus 242.4 is equal to 400 minus 242.4. This one is basically 157.6 equal to 5817.6. So the A is equal to how much? Divided by 157.6. So 5817.6 divided by 157.6 is equal to how much? 36.9 or 37. What answer given there? There, that 37 is there, right? Yes. So is equal to there the 36.9 something. Your answer is there 37. Okay. So this one 37. Clear? It's clear or not? Yes. Move to the next question. Very good. Next question is insulin contains 3.4% of sulfur. What will the minimum molecular weight? You know, this already we discussed this concept. The minimum molecular weight concept means there it is based on the minimum number of atoms present in the molecule, right? So when we say minimum molecular weight you are finding, and that also based on the sulfur. So that is based on minimum number of sulfur atoms in insulin is equal to 1. That cannot be less than 1 because that is not non-stoichiometric one. So the one 3.4%, let's assume molecular weight of insulin is equal to A. Very simple one. So 3.4% is the sulfur. So we write here the 3.4% of A molecular weight is equal to the minimum weight of sulfur. What is present here is minimum number of atom is 1. So the weight is 32. So you will write here 3.4 by 100 into there that A is equal to 32. Yes. So calculate here. A is equal to what? A is equal to 3200 divided by 3.4. This will be, just check it, 3200 divided by 3.4. This is coming here, the 941.1. Yes, given. Yes, 941 given. Yes, this is the minimum molecular weight concept. Okay, fine. Move to the next question. The chloride of metal contains 71% chlorine by weight. Right now, 71% chlorine by weight, and the vapor density also given 50. You have to find here the atomic weight of that metal. Okay. Vapor density is equal to 50. Then the molecular weight is equal to molecular weight is equal to 100. Molecular weight is 2 into VD. 100. You have been given here the chloride of metal contains 71% chlorine. Chlorine. Chlorine is 71%, 71 gram. Then their metal is metal. Is there 100 minus 29? 100 minus 70, 29 is the answer here. 100 minus 71 is equal to 29. Okay, 29 gram. Atomic weight of the metal, right? So molecular weight is 100, chlorine is 71 grams, so metal is 29 grams. So this is the atomic weight of this one, right? So what's answer? A. Atomic weight of that metal is this one. Okay. Move to the next question. When SO2 is passed through acidified K2Cr2 7 solution, Cr2SO4 thrice is formed. The change in valency of chromium. Okay. So let's see this one. K2Cr2O7. SO2 is passed. What forms already given? That is Cr2SO4 thrice given. What is the oxidation state of the chromium in the K2Cr27? This one is +6. You know it now? You have calculated, you know that how to calculate this oxidation number. Is it correct or not? There the K is the +1, 2 into +1. Chromium is there, that X, so there the 2X. 7 oxygen is there, the -2 is equal to 0. So what you are getting here, the 2x is equal to 7 to the 14, and this will come on that side. So the 14 and this one is -2 is equal to there the 12. So x is equal to there the +6. So oxidation is there the +6. Correct. Here what is this? Sulfate is having there the 2 minus charge. You know this one. So total is, you find it Cr2SO4 thrice. Cr2 there the 2x chromium. SO4 total is sulfate, 2 negative. So the 3 into there the -2 is equal to 0. So 2x is equal to there that 6. So x is equal to there the +3. Here the oxidation state is +3. Correct. SO2 is passed through acidified K2Cr2 so solve this, and the change in valency of chromium. Change in valency of chromium means plus 62 plus 3 plus 62 plus 3. Okay, see. Next question. Yes. The charge on the cobalt COCN63 minus. Cn already you know. What is the valency of Cn? Cn is mononegative charge. Cn minus 1. Okay. So there you can find it. For the cobalt, let's assume there that is the X. So there the X plus 6 into minus 1 is equal to 3 minus 3. Okay. So what you'll find here, you write it properly, minus 3. So what you write here, X is equal to, this will go that side, 6 minus 3 is equal to plus 3. So plus 3 is the charge on this one. It is correct. It is a straight question. You can solve this one very easily. Verbally you can solve. Okay, fine. Here the question is, in this equation, you have to find oxidized, reduced, everything. So for that, it's good. You write here MnO4 minus plus there the SO3 2 minus plus H plus. What that gives? That gives here the SO4 2 minus plus Mn2 plus H2. Okay, fine. Here you take oxidation state first. You have to understand this one. MnO4 minus. What is the oxidation state? Plus 7. Oxygen now 4 into minus 2. X plus 4 into minus 2 is equal to minus 1. 8 will go that side. So plus 7. Here what is this? 2 plus. Here what is this? SO3. SO3 minus 6. X plus 3 into minus 2 is equal to there that minus 2. 6 will go there. There that S X plus 3 into minus 2 is equal to 2 minus. So what you will get here? X is equal to 6 minus 2 plus 4. So here what is this? This one is plus. What is here? SO4 2 minus. Many times you have done. This one is plus 6. Okay, fine. Question is related to this only. What is happening here? Plus 7 2 plus 2. What is this? Plus 7 2 plus 2. Decrease in oxidation number. So this one is decrease in oxidation number. Decrease in oxidation number is reduction. It means MnO4 minus undergoes reduction. So this one is acting as reducing agent. This one is acting as this undergoes reduction. So this one is acting as which undergoes reduction. That is acting as which undergoes reduction, that is acting as oxidizing agent. Good. And SO3 2 minus, you see this one there, what plus 4 to plus 6, what is happening here? Increase in oxidation number, right? This one is increase in oxidation number. And so increase in oxidation number is oxidation. So which undergoes oxidation, that is acting as, yes. So this undergoes Oxidation, so this one is acting as reducing agent. Reducing agent. Now, let's come to the question here. What is the answer here? H plus, already you know there, this one is the H plus, and there also this one is the plus one only. So there is no change for the H plus. So you can't say anything. H plus, where it is involved, there is no oxidation or reduction of the H plus. MnO4 minus is reduced. Already you have seen this one. MnO4 undergoes reduction, reduced. SO3 2 minus is oxidized, right? MnO4 minus is oxidized, no, undergoes reduction, decrease in oxidation number. Okay, this is the answer. Fine. Next. Next question. Sulfur has the lowest oxidation number. Okay, you see this one, lowest oxidation number. For that, you will say H2SO3. Okay, there is H2SO3. What is the oxidation state here? In this case, this one is minus 6, 6, minus 2, plus 4. SO2, minus 4, plus 4. H2SO4, plus 6. Minus 8, we'll go that side. 8 minus 2, plus 6. H2S, sulfur, minus 2. Lowest oxidation number, H2S. Okay, done. Next question. The equivalent mass of MnSO4 is half of its molar mass when it is converted to, okay, equivalent mass is half of its molecular mass, equivalent weight mass. M by 2, it means N factor is 2. Change in oxidation number is 2. So in which case it is happening here? The one thing is very clear that MnSO4, you know. MnSO4, what is the oxidation state here? The plus 2. If this is converted to Mn2O3, what is the Mn2O3? Just to see this one. This is the minus 6. This side will go other side. That's a plus 6. Plus 6 by there the 2 plus 3. So oxidation state is plus 3. Changes there the 1. If this one is coming to MnO2, this one is 2 into minus 2, x plus 2 into minus 2, minus 4. That will go that side, plus 4. So Mn will be there the plus 4. Right? So plus 2, 2 plus 4, change is 2. Yes, this will be the answer. But at the same time, let's check here the other one also. Why not? MnO4 minus. MnO4 minus. What is this? There the 4, 4 into minus 2. That side is minus 1. So here the 8 minus 1 plus 7. Plus. And one more. MnO4 2 minus. So x plus 4 minus 2 is equal to minus 2. 8 will go that side. 8 minus 2 plus 6. So in which you see here the changes in this case, changes what? Changes 4. Here changes 5. Here changes 2. Here changes 1. What is the best one? What is the answer here? Change should be there the 2, then only equivalent mass will be molecular mass by 2. So answer is MnO2. Right. Good. Move to the next question. Equivalent weight of MnO4 minus in acidic medium, basic medium, and neutral medium. Already I discussed in the class that acidic one, MnO4 minus, is changed to Mn2 plus. There the n factor is 5. Equivalent weight is equal to what? Equivalent weight is equal to there that molecular mass by the other 5. Other one in there, in the basic meaning, in the basic, no? Yes. In the basic one, MnO4 minus is converted to MnO4 minus 2. So what is the change here? This one is plus 7, this one is plus 7, this one is plus 6 now. So equivalent n factor is plus 7 to plus 6, 1. Equivalent weight is equal to there that m by 1. Correct? And in the neutral medium, MnO4 minus is getting converted to MnO2. This one is plus 7, this one is plus 4. Change is 3, n is equal to 3. Equivalent mass is equal to m by 3. It is correct or not? What we have to find? We have to find there that in the ratio of, okay, and there we are getting here the equivalent weight in the acidic medium m by 5. This one is what? Basic medium m by 1. This one is m by 3. You take here one common multiple of this one, so we just multiply this one. 5 3 is 15, 15. This one into 15 into 15. What we get? 5 3 is 15, 15 3 5 is. So this one we are getting 3 is to 15 is to 5. 3 is to 15 is to 5. Okay. M3, M15, M5. Okay, fine. Move to the next one. In a reaction, H2O plus C gives CO plus H2, right? C in its native form, its oxidation number is 0. H2O plus C gives CO plus H2. There the oxidation number is 0. But this one is plus 2 because this one is minus 2 already, you know. H2 in its native form 0. But here it is minus 2 and this one is the plus 1. Very simple, very clear. 0, 2 plus 2 increase oxidation. Here the plus 1, 2, 0 decrease. Reduction. As this undergoes oxidation, so this one is acting as reducing agent and this one is acting as oxidizing agent. What is the question here? Carbon is H2O is the reducing agent. H2O is the oxidizing agent. This. Carbon is the oxidizing agent. No. Oxidation reduction does not occur. Okay. There is change in oxidation number, so it occurs. Next question. The hydrated salt of Na2SO4 NH2 undergoes 55% loss in weight on heating and becomes anhydrous. We did this question in the class also, right? So, what is the loss? Loss in weight is the loss of water molecules. Loss of NH2O that is 55%. So here, what is the percent of this one that we can find easily? The value of N will be, we can find the hydrated salt Na2SO4, NH2 undergoes 55% loss in weight, means NH2 is 55% of this one. So we can say here 55% of Na2SO4 NH2O is basically NH2O. Fine. So we write here N into 18, that is the weight of this, upon total weight of Na2SO4 NH2. What is this? 23 into 2 plus sulfur. Sulfur, what is the weight? 32 plus 4 into 16 plus N into 18 into 100 is equal to, this is the percentage of water in this one, given here 55. This is given. And how much it is? 23 into 2, 46. 46 plus 32 plus 64. 42 plus 32 plus 64 is equal to there 16 4 64. Oh, sorry. This one is 46 na 23. 2 ja 46. 46 plus 32 plus 64. 142. Okay. So N into 18 divided by 142 plus 18N into 100 is equal to 55. Okay, we'll do this one. We'll calculate the value of N. We get here 1800 N is equal to 55 into 142 plus 55 into 18N. Okay. So what is the 55 into 142? 55 into 142 is equal to 78. 7810 plus 55 into 18, 990 N. This one is 1800 N. So we write here that 1800 N minus 990 N is equal to 7810. So 1800 minus 990. We are getting here the 810 N is equal to 7810. So N is equal to 7810 divided by 810. What is this? 7810 divided by 810. We are getting almost 9.64. 9.64. Integer answer type. There you write here round figure. Okay. That is 10. 10 is 2. Yes. Done. You got it. I hope. Clear. Next you take here. Hemoglobin contains 0.33% of iron by weight. The molecular weight of hemoglobin is this much. The number of iron atoms present in one molecule of hemoglobin are. Okay. Molecular weight is equal to 67200. Molecular weight of hemoglobin. is 67200, 67,200. And hemoglobin contains 0.33% of iron. This is the molecular weight. So the weight of iron is equal to there the 0.33% of 67200. That you will get here the 0.33 divided by 100 into 67,200. Okay, this one is the weight of iron. How much it is? Just do this calculation here. 0 cancel, so basically this one is 0.33 into 672, right? It comes here 0.33 into 672, this one is 221.76. This one is weight of iron. Okay, weight of iron is this much. Then there number of moles of iron atoms, N of Fe, 221.76 divided by 56, because this is the atomic weight. So that should be divided by 56. That is 3.960. 4. The number of iron atoms, number of moles of iron atoms present in this one is equal to there the 4. Number of molecules, number of actual iron atoms is the 4 into Na, right? Good. Hemoglobin contains 0.33% of iron by weight. The molecular weight of hemoglobin is this much. So 0.33% of 67,200 is iron. We found here the weight of iron. And so there the number of moles of iron is equal to the weight of iron divided by its atomic weight, and we are getting this one. Done. Okay. Now, next one, 16 gram of SOX occupies 5.6 liter at STP. Assuming ideal gas nature, the value of X, very simple one. 5.6 liter at STP is equivalent to 16 gram. Then at STP, molar volume is 22.4 liter. 22.4 liter at STP, what we'll get here? 16 divided by 5.6 into 22.4 gram. 5.6 forja, and that's why we are getting here the 64 gram. 64 gram is the molar weight, because that is corresponding to the molar volume. So molecular mass is equal to 64 gram. Yes. Here SOX we have. So here we can write SOX or SOX. 32 plus X into 16 is equal to 64. Correct or not? So 16X is equal to 32. 64 minus 32. X is equal to 32 divided by 16 is equal to 2. It is SO2. Correct? Yes. Very good. In the following reaction, we have here the O3 plus there the 6I minus plus 6H plus, that gives here the 3I2 plus 3H2O. Correct? O3 in its dative form, so its oxidation state is 0, but here oxygen is in -2 state. And we don't have any other oxygen atom here. I is there already clearly there the -1, this one is the 0, so 0, 2, -2. per atom change is 2. How many atoms are there in O3? 3. 2 into 3 is equal to 6. So change of oxidation state per mole of O3 is 6. So molecular weight is equal to m by 6. Okay, good. This one you see now. The equivalent mass of an element is 4. Given equivalent. Next question. Mass is equal to 4. Okay. Do you remember? How do you find here the equivalent weight? You find here the equivalent weight is equal to there the atomic weight by there the valence. Is it correct or no? Equivalent weight is equal to atomic weight by valency. So its chloride has vapor density 59. What is the valency of the element? Yes, question is there the valency of the element. And there is a relation here. Its chloride has vapor density this one. Okay, we find it. Atomic weight upon there the valency. So atomic weight is equal to what? Atomic weight is equal to how much? Like E into there that valency. Okay. Now we find here its chloride has vapor density 59.25. Vapor density of chloride is equal to 59.25. So molecular weight is equal to weight of chloride is equal to 2 into Vt. 2 into 59.25. How much? This one. 100. 118.5. Huh? That only now. What is given? Its chloride has vapor density 59.25. Valency of the element. Okay. Chloride now. As it is chloride, so what is the formula for this one? Valency of the element is the question here. So chloride. Chloride is equal to formula of the chloride. Of chloride is equal to there that MClX. Right. The molecular weight is equal to here molecular weight. How you divide? MClX. MClX. Atomic weight is there the A plus 35.5 into valency is X is equal to there that 118.5. Okay. A is equal to E into valency, given there that A valency is equal to 4. So A is equal to there the E into 4. Yes. So here valency is X. Valency is X because MX plus XCl minus. That is the way. So what is the valency of M? Already we have assumed that the valency is X. So there atomic weight is equal to E into valency. Valency is there the equivalent weight given 4. Equivalent weight given 4. equivalent weight is equal to 4. So the atomic weight is equal to there that 4x. Yes. So this one 4x plus there 35.5x is equal to 118.5. This one is 39.5x is equal to 118.5. So the x is equal to 118.5 divided by 35.5. So what it comes? 118.5 divided by 35.5. This one will come, sorry, why 35? Why I have written? It is 39.5. Yes, this is 39.5. So what we are doing here, the 118.5 divided by 39.5, that is 3. Yes, so x is 3. Done. Thank you.